Hello and welcome to this video. So in this video I'm going to teach you how to set up your development environment for the C programming language on the Mac operating system. So there's a link in the description below that will bring you to this page where you can download Visual Studio Code, as we are going to be using Visual Studio Code as our code editor. So just when you get to this page, just select whatever operating system you're using and download it. So once you download it, just to run through the installation and install Visual Studio Code. So once you've done that, I want you to open Visual Studio Code, and then once you open it, there are a few configurations that we're going to need to make. So as you can see, this is just a basic C program that prints hello world. So I would want you to first of all go towards the extensions icon, click it, and we're going to need to install two extensions. So the first extension is the C and C++ extension. Just type CC and it should bring out this extension, the one by Microsoft. So just click it and it should bring you to this page. Now I'm going to need you to hit install. So once you hit install, we now need to download the second extension that we need. So once this is done installing, just come over here back to the extensions and search for code runner. So code runner, this one, so it's the first one by John Han. So once you click it, just install this extension also. So when this is done installing, I would want you to go to your settings, then click extensions. Now once you're in, I want you to go to settings and click settings again. Now once you're in your settings, I want you to click extensions. Now scroll down, and then we are looking for run code configuration. So just click that. Now once you've clicked that, I want you to scroll down right here up until where you see run in terminal. So right here. So for you it's probably unticked, so just make sure you tick it, and then once you've ticked it, just close the settings tab. So once you've done that, just close your VS Code and open it again so that all the changes can reflect. So after you've done that, we can now go ahead, and I am just going to test this C program to see if it works. So once I run it, you can see it's printing out hello world in the terminal. So that means the installation works properly. If you're having any errors, you can just leave a comment in the comment section and I will reply you. So in this video we talked about how to set up your development environment for C on the Mac operating system.
In this video, I will teach you how to set up a development environment for the C programming language on a Windows operating system. The first step is to install Visual Studio Code. We will use VS Code to write our C programs. A link to this page is in the description. Once you are on the page, you can hit the download button to get VS Code, or click the arrow down button to pick whatever operating system you are using. After downloading, install it on your computer. The next step is to install the MinGW compiler. We need the compiler in order to convert programs that we write in C into machine code that the computer can understand. There is a link to this page in the description below. Next, hit the download button. The download should begin after 5 seconds. When download is done, open the exe file. Next, click install and click continue. I have MinGW installed, so I will click reinstall. For you, click continue and wait for it. After installation, hit continue. You will be brought to this window. We will be installing the GCC, G++ compiler. Tick it and click Mark for installation. I have it installed, hence why it says unmark. Next, click Installation and click Apply Change. The setup was successful. Now you can click Close. The next step is to add min.gw to path. Head to this PC in your File Explorer, and follow to the path you see on the screen. Next, copy the file path. Then click the Windows icon or button, and type env. Click the result that comes up. Next, click Environment Variables. After, click Path and click New. Next, paste the path you copied and click OK, and OK. I will then proceed to test my C program in Visual Studio Code, to see if the setup works. I wrote a C program that prints Hello World. Let's run the program.
So in this video, we are going to be writing our first program in C. So as a form of tradition, we are going to be printing out Hello World in the terminal. So the first thing I want you to do is create a folder where you are going to keep all your C files and your practice files that you are going to use in this tutorial, so that everything can be structured. So I would create a folder and name it C tutorial. C tutorial. I didn't spell that right. T-U-T-O. Okay. Now once you've done that, I want you to open your Visual Studio Code. Now if you haven't installed Visual Studio Code, or if you haven't set up your development environment for programming in C, there's going to be a link in the description below that takes you to the last video. And in the last video, we talked about how to set up the C development environment. So once you've opened your Visual Studio Code, just click this icon right here and then hit open folder. Now I want you to locate the folder that you just created. This is mine, so just open this folder. Now the next thing that we are going to do is we are going to create a file, and then we are going to name this file. You can name it whatever you want, but I would name mine hello.c. So you can see the file has been created for us. So basically, I am not going to be explaining the code that we're going to write in this video. So it's just like an introduction, and we're just printing out Hello World. But in videos that are coming in the future, in future videos in this playlist, we're going to talk about everything that is being typed here, and I'm going to break the concepts of C down so you would understand. So the first thing that we'll do is we would say is include angle bracket stdio.h, stdio.h, and then close the angle bracket. And then the next thing we now need to do is say int main, open parenthesis and close it, and then open curly bracket. And then what we now need to say is printf, open parenthesis, and make sure it's double quotes that you create. If not, it's going to give an error. So just say hello world and then \n for a new line, and then a semicolon. So after doing that, we would return 0. So like I said earlier, in future videos we're going to talk about what each of these things mean. I am going to explain it. So now we need to run this code in the terminal. So just right click or come to this icon right here and click run code. So you can see in the terminal it prints out hello world. So we have successfully written our first code, our first program in C, and it's print hello world. So printing hello world is like a tradition. So if you're learning a new language, I guess you would also want to print hello world. In this video, I will be explaining what variables are and how we can use them in our code. So I just have these 7 lines of code that I had written earlier, and I'm going to be explaining what these lines mean, but I will not be going too deep into the explanation because they are not the main focus of this video. But in time, as you watch more videos in this playlist, you would understand what each line means and what function is performed. So we have the first two lines. We have this hashtag include, and then we have two angle brackets and some text in between the two angle brackets. So these are called libraries. A library is an external, you can just look at the library as some external code that has been written by somebody else that we can import into our code and use. So what this means is that we don't have to write the same code again because somebody else has written it, and we can just import it into our code and make use of it. For example, this first line, include stdio.h. This library stdio.h, it means standard input output header. So this library makes sure that data can be printed out in the terminal, and data can also be entered into the terminal. For example, if I try to print something, if I say printf and I say I am a YouTuber, and then I put a \n here and end it with a semicolon. Once I run this code, you would see it prints out I am a YouTuber. Now the fact that data is being printed out in the terminal is being owned to this library. So this library ensures that data can be printed out in the terminal, and data can also be entered in the terminal. So the next thing we have is just this int main with parentheses and curly brackets. So just look at it as a container that can house a whole that can house a bunch of code or chunks of code. So what this is called is a method or a function. Now you can have several methods and several functions just like this in your code, but the main is different. Anytime you have a function named main, it means that every single code that is written inside that function is always going to be run. Now for example, I could have another function named void age or something like that, and I could just create a function like this. This in itself is a function. Now anytime the computer runs this program, the function that will always run first, and the function that will always run as a matter of fact, is this main function. So anytime you want to write any code that you want the computer to run, you must always write it inside the main function. Now there are also ways for you to create other functions and reference them inside the main function so that they can be called. But this video isn't about functions. In the future videos, I will explain what functions are and how you can use them. So I am just going to clear this out. Now to the main course of this video, variables. So what exactly are variables? You can look at a variable as a container for a specific value or a placeholder for a specific value. It's just like in mathematics, when you're looking for an unknown value, you would say let the unknown value equal x or equal y. X or y in that scenario becomes the variable, and then the unknown becomes the value that you are trying to assign to that variable. So as an example, if I wanted to create a variable and save my age in that variable, I would say int main. Now I'll explain why we're saying int. Sorry, not main, int age, and I would equate that to, let's say 67, and then end it with a semicolon. Now the reason why we're ending each line in a semicolon is because it denotes the end of a line. So the semicolon means, okay, we are finished writing for this line. And then these curly brackets also similarly mean the same thing. It denotes the start of a function, that is the start of all the code in a function, and then the closing one denotes the end. So back to the variable. So why exactly did we put int before the variable age? Now the reason why you put int is because in C, before we create a variable, we always have to specify what kind of data type is being assigned to that variable. So what I mean is, the fact that we're assigning 67 to this variable means that we're assigning an integer to the age variable. So the age variable is going to house an integer. Now because it's an integer, we have to tell C what kind of data type it is. So we have to say int first. Now in the next video, I am going to explain what data types are and why we always have to specify what kind of data type a value is before we can assign it to a variable. But for the main course of this video, I just want you to understand what a variable is. A variable being a container that you can just assign a value to. So if I want to access this variable, if I would like to print this variable out to the terminal right here, what I would say is printf, and then make sure it's in double quotes. So once I do that, I will just say my age is %d, and then I'll put a comma here and pass in age, and make sure you end it with a semicolon. So why exactly do we pass in %d? This is called the printf formatting. So in order for you to print out an integer to the terminal, you have to pass in %d. If it was a different data type, you would have to pass in something else. So in videos to come, you would understand what this means and why we're passing in percent signs and what exactly this means. So once I run this code in the terminal, sorry, I didn't save it, so let me save it and clear the terminal. Once I run this code in the terminal, you can see it says my age is 67 and I am a YouTuber. So if I put a new line, \n stands for new line. So if you want to create a new line, you put \n. So once I run this again, you can see it says my age is 67 and I am a YouTuber. So I just want you to understand that a variable is a placeholder or a container for a particular value. Now we could also come over here and create a different variable, and we could equate that to my name. So I would say char and then name, and I would pass in, let's say 5, and I will equate that to AYO. Now let's end that in a semicolon. So what I have done here is I have created a variable and named it, and let me just change this to my name. I created a variable and named it my name, and I am equating that to IO. Now just ignore this this bracket and this 5. So once let me try to print out my name now. My name is, I would say %s, and I will pass in my name here. Now in future videos, I am going to explain what each of these things mean. So this error is supposed to clear out. So once I run that, it says, okay, let me assign this double quote. I think the error might be coming from there. So once I save that and clear out my terminal, you can see it says my name is IO. So basically what I have done now is I created a variable that contains my name, and I am printing it out here. And you can see I passed in %s because I was trying to print out a string. So in the last video, we talked about variables and how we can declare variables. So in this video, we are going to talk about two types of variables, and then we're going to talk about variable naming conventions. So the two types of variables that we're going to be talking about in this video are the constant variable and the local variable. So you can see before I had started this video, I had added the const keyword before this int age. Now what is a constant variable? A constant variable is a variable that is immutable. What it means is that it can't be changed. The value assigned to this variable will always be constant, so we cannot change this value. We cannot assign a value to a constant variable. So the value assigned to this variable is always constant and cannot be changed. And if you want to create a constant variable, all you have to say is const, then the data type, then age, then the name of the variable. For example, if I wanted to make this variable a constant, I would say const, then the data type, which is char, and then pass in the variable name, and then assign the value to it. So what that means is I cannot change the value that has been assigned to the my name variable, and it also means I cannot change the value that has been assigned to the age variable. So I hope you understood that. If you didn't really understand it, I want you to watch it again, or you can leave a question in the comment section and I would reply you. So the next variable type that we are going to be talking about is the local variable. So earlier we said that the constant variable is the variable that is a variable whose value cannot be changed. It is immutable. But then there's another variable type that we can create that can be changed, which is the local variable. So for example, I could say int num is equal to 3, and then I could also come down here and say num is equal to 5. Now once I run this command, this code rather, we can see that it doesn't crash. So what this means is that anytime we declare a local variable, we can change the value of that variable later in our code. So that is the difference between a local variable and a constant variable. A constant variable cannot be changed, but a local variable can be changed. And here I could say printf, and I could say number is %d, and just to show you that the number actually changes, so I'm going to pass in num here. So let me just say \n and put a semicolon at the end. So once I run this code, you can see it says number 5. So when we created this variable, the initial value was 3, but then we reassigned the value of that variable to be 5, and then when we print out the value, you can see that the value changed to 5. So that is the difference between a constant variable and a local variable. So the next thing that we're going to be talking about is variable naming conventions. So when you want to create a variable, how exactly should you name your variable? What should you name your variable, and what is allowed and what isn't allowed when you are trying to name a variable? So the first variable convention that we're going to be talking about is the snake case. So basically, what this means is anytime you are trying to create a variable, for example, if I wanted to create a variable and say my book, I could decide to name it my underscore book. This right here is called a snake case. It's called a snake case variable naming convention. Now the way you know a snake case is that each word is separated by an underscore. Now it is advised that you shouldn't start a variable using a number. For example, if you say one book, you can see it's already giving an error. A variable name cannot start with a number. It either has to start with an underscore or a letter. So you cannot start a variable name with a number. The number can come after an underscore or a letter, but a number should never or can never start a variable name in C. So the first variable convention that we're going to be talking about, like I said before, is the snake case. So if you want to create a variable and follow the snake case naming convention, you could say number of students. I'm sorry, this is S. Number of students. So you can see each word is separated by an underscore. So I am just going to put a comment here and name it snake case convention. So CONVEN. So this is the first naming convention that we're going to be talking about. Then the next naming convention we're going to talk about is the camel case. Now in the camel case naming convention, this is when each word is separated by a capital letter except the beginning word. So let me just show you what I mean. So I could decide to, let me comment this out. I could decide to create this same variable. Oh, I don't need to comment it out. I could decide to create this same variable, but I will name it number of students. So this is the camel case naming convention. You can see other words start with an uppercase letter or a capital letter. That is excluding the beginning word for the variable. So aside the beginning word for the variable, every other word in the variable starts with an uppercase. So you can see number starts with the n is in lowercase while the other word starts with uppercase. So this is the camel case. I'm just going to comment this here and say the camel case convention. And then the next and final convention that we are going to talk about is the Pascal case. Now the Pascal case is very similar to the camel case. The only difference is that each word in the variable always starts with a capital letter or an uppercase letter. So if I wanted to use the Pascal case, I would say int number of students. So I will just name this the comment this the Pascal case. So in the Pascal case, every word starts with an uppercase letter. So to recap on what we've talked about, anytime you want to create a variable, you can follow any of the 3 cases that were just described, and there are more cases, but these are the commonly used cases. So the first one that we talked about is the snake case. This is when each word is separated by an underscore. And then second one we talked about was the camel case. This is when each word is separated by an uppercase letter. That is, each word after the first word is separated by an uppercase letter. And then the last one, which is the Pascal case, is when every word is separated by an uppercase letter. And then we also talked about 2 types of variables, which is the constant and then the local variable. So in this video, we're going to be talking about data types in C. So I had already created a file named datatypes.c. So we're going to be talking about 4 basic data types, which are the int, double, char, and the string. The string isn't a conventional data type in C, but I would explain more about it when we get there. So when we are trying to create a variable in C, we have to tell C 3 things. The first thing we need to tell C is what kind of value are we assigning to this variable. That is, what kind of data type are we assigning to this variable. Then the next thing is we need to pass in the variable name, and then we need to pass in the value that we're actually trying to assign to that variable. Now, we need to take note of the fact that I said data type. Now, there are different data types in C, and then anytime you're trying to assign a value to a variable, you have to declare what data type it is first. So we're going to start with the int data type. Now, when you are going to be working, when you are working with C, you are going to notice that you are going to be making use of numbers a lot. So in order to store numbers in a variable, we need to first declare what kind of variable it is, which is int. And then after that, we need to type in the name of the variable itself. So I would say like age, and then you now equate that to the actual value. So I'm just going to say like 26 and then put a semicolon. Now, the int data type is used to declare that we are trying to assign a whole number to a variable. Now, a whole number is a number that doesn't have like any point. It's just 26. Like 26 is a whole number, 97 is a whole number. It doesn't have any point. So that is what an integer is. An integer is basically a whole number. So anytime you declare a variable to be int, you have to assign an integer to that variable, or else you are going to have errors. Now we can decide to print out this age. So I would say printf, and then I'm going to pass in my %d and then age. So in order to print out integers, you have to pass in %d into the printf function, and then you pass in the actual variable that you're trying to print out. But in the next video, we're going to be talking about printf, and you would understand more about this. So once I run this, okay, let me put the \n here so that you can see that well. So once I run this, you can see it prints out 26 in the terminal. So the next data type that we're going to be talking about is the double. So earlier I said once you want to assign a whole number to a variable, you have to declare it using the int data type. But what if you want to assign a decimal number to a variable? What do you use? You use the data type called double. Now, double is used to declare that you are trying to assign a decimal number to a variable. For example, I could I could create a variable, declare a variable as double, and I would name it grade, and I would equate that to 54.6. Now what I have done here is I have created a variable called grade, and I have assigned a decimal number or a float to this variable. Now in order to declare decimal numbers, again we have to use the double data type. Now if I was to assign this int and I said print age here, I want you to note what would happen. If I run it, you can see it's already giving an error because we've assigned int to this data type and then we're giving it a decimal number. So I want you to always take note that anytime you are trying to assign a data type to a particular variable, the value that you assign to that variable must be equal to the data type. So here I can try to print grade right here, and then anytime you want to print a double or a decimal number, you always have to pass in %f. Again, you are going to understand more about this in the next video where we talk about the printf function. So once I run this, you can see it prints out 54.60000. So that is that about the double data type and how to declare decimal numbers. So the next data type that we're going to talk about is the char data type. So let me just comment this out. Int data type, and then the double data type. So the next one that we're going to talk about is the char data type. So the char data type or the character data type is used to assign a single character value to a variable. So what I mean is I could create a variable and name it char level, and I would equate that to a. Now what this means is that we've created a variable named level, and then we've assigned a single character to it, which is a. Now I want you to take note of something. Anytime you declare the char data type, you must only assign it to one character, and it must be in single quotes. So if I were to pass in other things into this into this quote here, once I run it, you can see it is crashing. So you must always assign one character to the char data type. So once I run this, you can see everything is working fine now, and it must be in single quotes. You shouldn't use double quotes. So that is that about the char data type. It is used to represent single characters. Now the next data type that we're going to talk about is the string. Now this isn't like a conventional inbuilt data type in C. So the way we create a string is we say char, and then I can say name, and I will put an empty list here. And now I'm going to explain what this does, but I'll put an empty list here and equate it to the proton guy. Sorry, the proton guy. So basically, what have we done? We have used the char data type to try to just stringify a list of characters. So we're trying to just zip a list of characters into one input. What that means is normally the char data type is responsible for collecting only one character, but if we want to declare a string, we would have to pass in the char data type, then the name of the variable, and pass in a list here and empty brackets. So once you've done that, you now equate it to whatever value you want, and take note that it must be in double quotes. If I were to change this to single quotes and I run it, you see that it is crashing. So it must be in double quotes. So that is how to declare a string. Now you could also, if you would want to print out a string, you could say %s, you would say %s, and then you would pass in name. So let's clear out the terminal, and then once I run this, okay, it's giving an error saying okay, I didn't put a semicolon at the end of that. So let's run that again, and then you can see it's printing out the proton guy. So that is how you can print out a string. You pass in %s. And I forgot, if you also want to print out a single character, which is this in line 10, you would pass in %c, and then here I would say level, and then once I save that and run it, you can see it's printing out A to the terminal. So those are the simple data types that we're going to be talking about in this video. So we talked about the int. It is used to declare that we are trying to assign a whole number to a variable. We talked about the double, which is used to assign a decimal number to a variable. And then we talked about the char data type, which is used to assign a single character to a variable. And then we talked about the string, which is a way of zipping a bunch of characters together to become one. So we do that by saying char, then we pass in the name of the variable, and then we put these two square brackets and equates that to the value that you are trying to assign to this variable, and it has to be in quotes. Now in future videos you are going to understand why we put this square bracket here. So thank you for watching this video, and in the next video we're going to talk about the printf function. Please like, share, subscribe, and I will see you in the next video. So in the last video we talked about the different kinds of data types that we have in the C programming language. So in this video we're going to be talking about the printf functions. So I'm going to teach you how to print different things like strings, integers, and variables to the terminal. So the basic syntax of the printf is just printf, and then inside this parenthesis here you pass in whatever you want to print out. So for example, if I wanted to print a string, I would say I could say I am a YouTuber, and then you have to put a semicolon at the end of the line. So once I run this, you'll see that it's going to print out I am a YouTuber. Now I want you to take note of something. I want you to take note that this has to be in double quotes. If we replace this with this single quote, you will see that we will get an error. So once I run this, you'll see that it's already giving an error. So make sure that anytime you are printing out to the terminal, make sure it is in double quotes. So this is how to print a string I am a YouTuber. It has to be in quotes. So what we can also do is we can print out strings with special characters. For example, if I wanted to print out two things in one print statement, I could put a \n right here, which signifies a new line, and I would say please subscribe. And then once I run this code, you see that I'm a YouTuber gets printed out first, and then please subscribe gets printed out in the next line. So we can add some special characters like the \n, which signifies a new line. So that is that about printing strings. Now the next thing that we need to talk about is how to print like numbers and integers. So let's say for example I wanted to print out a person's age. What we need to do is that we need to pass in a specific format specifier. So what this is going to do is it's going to act as a placeholder for printing out some specific values. Format specifiers help C know what kind of data type we are trying to print to the terminal. So if we want to print out a number, we say %d, and after passing in %d, right after the quote, you put a comma, and then you pass in what number you want to print out. So I could pass in like 90 for example, and then once I run this code, you'll see that 90 gets printed out in the terminal. So that's that about printing numbers. You could also print strings with numbers. So what I mean is we could type your age is %d years old, and then once I run this code, okay, I'm getting an error. Let me run this again. So once I run this, you can see it says your age is 90 years old. So this is how to pass in numbers, or how to print out numbers using the printf function. So we use the %d format specifier, and then we have to put the comma and then pass in the actual value that we are trying to print out. So the next thing that we need to learn is how to print out strings, or how to print out strings to the terminal. So for example, let's say you didn't want to write this your ages. Instead, you wanted to pass it in as a variable into the printf statement. What we could now say is we could remove this your age is, and then we could put %s right here. And then after doing that, we need to pass in this your ages right here. So I'm going to explain why we're doing this. So what we are basically doing is, if you want to pass in a variable or a string into the printf function, you have to pass in %s. So %s is going to be the format specifier for the string you are trying to print out. So if we save this and run this file, you can see it still says your age is 90 years old. It says your name is 90 years old because first of all, we've passed in %s, and then %s is the unique identifier for your age is, and then we now have %d, which is the unique identifier for 90. So hence it says your age is 90 years old. So that's how to print a string to the terminal, or passing a string rather to the printf function. So what if you wanted to print out a decimal number? So right now this is an integer, a whole number. What if you wanted to print out like 34.56? If we try using %d, it's going to give us an error. We need to use a specific format specifier, which is %f. So this is just going to help us print out floating point numbers or decimal numbers. So once I run this file, you can see it says your age is 34.56000 years old. So that is how to print out decimal numbers to the terminal using the printf function. Now I want you to take note of this. The order of the format specifiers should match the order of the way the values are passed in. For example, if I pass in 34.56 first, and then I pass in your age is after the 34.56. If I run this, we are going to get an error. Actually, it doesn't even run. Well, let me try running it again. So it doesn't run at all. So the reason why this happens is that we first passed in %s. So the program is expecting that we pass in a string first, and then we now pass in %f. So after passing in the string, it's now expecting us to pass in the decimal number. So that is why the program didn't run. So what you can take from that is the order of the way the format specifiers were specified should be the order in which the values are passed in. So that is how to print out decimal numbers and how to print out strings. But what if we wanted to pass in a variable here? What if we didn't want to like manually type it in? I could just come to the top and create a variable called age, and I could equate that to this 34.56, and then instead of manually passing it in here, I could just pass in age into this printf function, and then once I run it, you'll see that it still runs perfectly and it still runs smoothly. I could also do the same for your age is, and I could come here and create a char. I could come here and just call this text, and I can equate that to your age is, and instead of passing in your ages right here, I could just pass in text. So once I save this and I run this file, you'll see that it still says your age is 34.56. So this is how to pass in strings, integers, variables into the printf function. So that is all you need to know concerning the printf function to really get started with C. So thank you for watching this video, and I will see you in the next one. Also, if you have any question, you can leave it in the comment section and I will reply you immediately. In the last video, we talked about the printf function, and we talked about how to print out different data types and then the different kinds of format specifiers that we have. So in this video, we're going to talk about basic numbers, numbers and basic arithmetic. That is adding basic numbers, subtracting numbers, dividing and multiplying. And then we're also going to look at some cool things that we can do with the math.h library. So if we look at this right now, we're just simply printing 5.7 to the screen. And then once I run it, you see that 5.7 gets printed out in the terminal. So what we can now do also here is we can decide to add two numbers together. For example, I could add 5.7 and 8. I could pass that in as a value for this format specifier, and then once I run this, you can see it added them together, 13.7. So knowing having this information, we can simply perform other operations like subtraction. And then once I run that, you can see, you can see 5.7 minus 8 is negative 2.30. And then we can also perform multiplication. So if we try to multiply those, you can see it gives us 45.6. And then also we can do division. So once I run this again, it gives us 0.71. Now I want you to be careful and take note of this singular factor. Any format specifier you pass into the printf should have a data type that matches that specifier passed into it. So what I mean is, if we try to pass in 9 into this printf, saying that we want to print out 9, if we run this code, let me run this, you can see it prints out 0. The code isn't working properly because in here we said %f, so it's expecting a floating point number, that is a decimal point number. So if I decide to add 9.0 and then I run this code right here, you'll see that it prints out 9. And then if I run 9.9, for example, if I change it to 9.9 and I run this code, you can see it prints out 9.9. So since this is a floating point number, we should always use %f, because %f is the format specifier for floating point numbers. If I change this from %f to %d right now and I try to run this, you can see it gives us a very weird number, and that isn't the number that we passed into the terminal. So it's giving us a weird number because this is not a whole number, it's a decimal number. But if I change this to just 9 and I run this code, you see that it gives us 9 right back. So the format specifier should always match the value that is passed in. So another cool thing that we can do is that we can actually make use of the math.h library to do some cool math calculations. So I am going to say hashtag include math.h. So this is a library that basically has inbuilt functions that can help us perform square roots and different complex math problems. So for example, if we wanted to find 2 raised to the power of 6, what we would simply say is pow, P-O-W, which stands for power, 2,6. So right here, what we're saying is 2 raised to the power of 6. Now, I want you to take note that if this is %d, it won't work. If you're trying to use the power function and then you pass in %d, it will not work. So let me show you that right now, you can see it gives us 0, but 2 raised to the power of 6 is not 0. So we need to change that to %f, and then once we run this file, you can see it gives us 64. So you can make use of the power functions to find like the power of a particular number. So if you want to find 5 raised to the power 7, you pass in 5 here, and then you pass in comma 7. So once we run this, it gives us 78,125. Another cool thing that we can do is we can find square roots. So let's say we wanted to find the square root of 36. We could say sqrt, and the sqrt is a function that exists in the math.h library. So you say sqrt 36. So if I run this code right now, you see that it gives us 6.0 because the square root of 36 is 6.0. So in this video, we're going to talk about comments. So basically, comments have two main uses. The first use is to disable like a section in your code. For example, if I wanted to disable this line 7, I could use a comment. And also a comment is used for writing like little descriptions in your code that explain what a particular place in your code does. So in order to explain this properly, if I wanted to comment this line right here, line 6, you can first create 2 forward slashes. This is the first way of creating a comment in C. So I can say in line 6, I am creating a variable named age, and it stores my age. So basically, this is just a simple way of writing a comment, and anytime you run your code, whatever line that is commented out, whatever line that is commented will not run. So if I wanted to disable line 8 right now, I will just put 2 forward slashes in front of it, and then line 8 is going to be disabled. So if I run this right now, you'll see that nothing happens because line 8 has been disabled, that is the printf. But if I uncomment it, I run this, you can see it prints out I am 9 years old. Now there's also another way of creating comments. The other way to create a comment is you type a forward slash and then an asterisk. So if you are not using Visual Studio Code, this might not be auto-completed for you, but if you want to create a comment using this method, just type in a forward slash, 2 asterisks, and a trailing forward slash. So inside these 2 asterisks, you can now write whatever you want, like the line 12 is responsible and blah blah blah. So you could just write whatever you wanted between these 2 asterisks. So the main uses for comments is they help to like write descriptions in your code, so that even when you come back to your code like 3 months later and you read the description, you can understand, okay, this particular line does this, this particular line does this. And then they also help us to kind of temporarily disable a particular line in your code. So let's say you do not want that line to function, you could just put a forward slash, and then when the C language, when the computer is running your program, it's going to completely ignore that line. So whatever line that is commented is going to be ignored. So those are the two main functions of comments. They help us document our code, that is, give descriptions of what like a line or a section of your code is doing. And it is generally recommended to always document your code, because if you're working in like a company, for example, you might be working with other people, and then you would want to write code in such a way that when other people look at it, they understand what you had written. So you can leave in comments that describe what like a line does, or a comment that describes what a chunk of code does, so that when like your coworker is reading it, the person will understand exactly what you wrote. So that is all for this video. We talked about comments. Thank you for watching this video, and I will see you in the next video. In this video, we're going to talk about constants in the C programming language. So a constant is a variable whose value cannot be changed. So the value is immutable, meaning that if we assign, for example, as we have assigned 50 to the variable age, if age was a constant variable, we will not be able to change the value. So I'm going to show you an example now. Because this isn't a constant variable, we can change the value below. So I can come down and say age is equals to 100, and then I can also now come down to print age. So you are going to see that the value of age actually changes from 50 to 100. So once I run this code, you see that it first printed 50 and then it's printed 100, because at first we set the age of 50, we set the value of age to be 50, then we change the value of age to be 100. So that is why it's printed 50 and then 100. So this isn't possible using constant variables, because again, at the beginning of this video, I said the value of a constant variable cannot be changed. So how exactly can we create a constant variable? We can do this using the const keyword, and we can do it in two ways. We can decide to pass in const and then the data type, then the name of the variable, and equate this to 50, or we can pass in const right after the data type. So we can also say int const age is equals to 50. So this is just declaring that we are setting the variable age to be a constant variable. Now notice what happens when I run this code. Once I run it, you can see that it's giving us an error, because at the top we had declared that age is a constant variable. Since age is a constant variable, it means we cannot change the value. So the error is coming from line 8. So we can just simply remove those two lines, and then if we run the code again, you can see that everything is working smoothly now. So basically, the value of a constant variable cannot be changed. Now there's also something that I need you to take note of. It is like industry standard to always name constant variables uppercase letters. So for example, instead of saying age in lowercase, I will say age in uppercase. So it's more of like an industry standard type, I would say, paradigm. So anytime you're creating constant variables, you can either put the const keyword before the data type or after the data type, followed by the variable name, which is supposed to be, or which is according to industry standards supposed to be uppercase, and then you now equate this to the actual value. So that is all we are going to talk about in this video. In this section of this course, we are going to talk about how to collect user inputs from the terminal. So if you're working on a project, you might reach a point where you need the users to enter some specific data. So in this video, I am going to teach you how to collect user inputs from the terminal. So the first thing that we're going to want to do is, for example, if I wanted to collect somebody's age, I would need to create a variable to actually store that person's age. So first, I'm going to create a variable and call it age, and I won't equate this to anything. I will just create a variable at the top because I want to equate whatever the user has inputted to this variable later on. So the next thing that we now actually need to do is prompt the user to actually enter something into our program. So I'm just going to say printf, and I will say kindly, create double quotes first, and I'll say kindly enter your age. And after doing that, I'll just put a semicolon, and then the next line that we're going to write is actually the main line, and it is called scanf. So basically, it's just like the opposite of printf. Printf helps to display some specific text or data in the terminal, but scanf helps to retrieve or collect or basically scan data from the terminal. So the first thing that we need to pass in here is we need to specify what kind of data we are collecting. That is, we need to specify the data type. So we need to tell C whether we are collecting an integer or a double or a string. So since we are collecting an integer, I'm going to say %d. Now I am saying %d because %d is a format specifier for integers. So the next thing we need to specify is we need to tell C where we want this value or this data to be saved, because we've collected this data from the terminal now, but we now actually need to save it or store it somewhere. So the way we do that is by saying %age. We're saying %age because we are trying to point this data to this age variable that is at the top. So the first thing we do is we use %d, which is a format specifier, to specify what kind of data is being inputted into our program, and then we put a comma, and then we now put this symbol, it's %, and then we pass in the name of the variable that we are trying to store this data in, and then don't forget to put your semicolon. So after doing that, we can just print out this data to the terminal to actually show that we've been successful in collecting this data from the user. So I'm just going to say printf, and I'll say your age is %d, and after doing that, I'll just put a comma and pass in age right here. So I am going to run this code right now. It's supposed to be printf. Okay, so let me run this file again, and then you see that the program says kindly enter your age. So I'm going to say 89. So you see it prints out your age is 89. So our program was successful in collecting the age of a user, and it stored that age, and then it's printed it out in the terminal. We can also collect something else like grade. I can create another variable and call it grade, and I won't equate this to anything yet. So we are going to request the user to enter their grade. So I'm going to prompt them again and say printf, and I'll say kindly enter your grade. So this is just like prompting the user to enter a grade. Next, we are going to say scanf, and because we are entering a character, that is, it's a letter, whether it's A, B, C, D, E, or F, since we are entering a character data type, we are going to say %c, because %c is a format specifier for the character data type. And the next thing, as usual, is to point to the grade variable, because we want to store this person's grade inside the grade variable. So after doing that, we can now also print out the grade. So after saying your age is %d, we can now also say and your grade is %c. After saying %c, we put a comma and pass in grade into this printf. So let me clear out the terminal. So once I run this code, I'm getting an error. Okay, it's supposed to be grade. I spelled that wrongly. So once I run this code in the terminal, you can see it first asks us to enter grade. So I'm going to say A. Then next it says enter your age, and I would say 28. So once I run that, it says your age is 28 and your grade is A. So basically that is how to collect user inputs from the terminal. Now you can do this with different kinds of data types. You can do this for the int, the char. You can even collect a string from the terminal. So that's basically how to collect data from a user in the C programming language. In this video, we are going to talk about arrays. So if you look at the screen right now, you can see there is just a variable called age, and it is equated to a value of 17. Now note that this value is here, this variable age is equated to one value. But what if you wanted a way to store multiple values? Like for example, if you wanted to store multiple ages inside the age variable. So if you wanted like a list of ages to be assigned to the age variable, how could we do it? Now we can do this using an array. So an array is just basically a data structure that can help to store multiple values and assign it to a particular variable. Now I am going to teach you how to create and work with arrays right now. So let's say for example we wanted to store multiple ages in this age variable. What we need to do first is declare what data type int, and then create the name of the variable, which is age, and then we're going to put in this square bracket. Now what we need to do inside the square bracket is that if you know the number of items that you want to store inside this array, you can pass it in, for example 5. Now what that means is that once we've passed in 5, it means that we cannot store more than 5 items inside this array. Now if you do not know the specific number of items that you are going to be storing inside an array, you can just leave it empty and your program will work properly. So after doing this, we are going to equate it to curly brackets. Now this curly brackets, inside this curly brackets is where we are going to be writing all the items that are actually going to be stored inside this array. So for example, I could type in 12, 16, 76, 90, and our code is still going to run properly. And make sure you put the semicolon at the end. So what we have done now is we've created an array called age, and then we have equated it to 4 items. So once I run this command, or code rather, you will see that we have no error. Now what if you want to access a particular item? For example, if you wanted to print 12 or if you wanted to print 90, I am going to show you how. So we're going to say printf, and then inside this printf we first need to pass in %d because we're trying to print out an integer. Now what if we wanted to print out 12? We are going to print out 12 using what is called indexing. So I'm going to say age and then create 2 square brackets and pass in 0. So what exactly is this? Now inside an array, every single item is located at a particular index, and using indexes is a way we can access specific values in an array. And then every single array always starts with an index of 0. So 12 is going to be sitting at an index of 0, 16 will be at 1, 76 will be at 2, and 90 will be at 3. So to prove that the code works properly, once I run this file, you can see that it prints 12. And if I wanted to print 90, I would pass in an index of 3 because it's at index 3, 0, 1, 2, 3. So once I pass in 3 into this code and I run it, you can see that 90 gets printed out in the terminal. So basically now you've learned how to create arrays. Now what we can also do is that we can also modify the value of arrays using indexing. So what if we wanted to change the value of 90 to like 950? What we can say is age, and we create curly brackets and pass in the index of where 90 is, and then we can equate that to 950. Again, what we are doing is we are trying to change the value of 90 to 950. So the way we can modify it is, first we need to grab 90 by the index. So we're saying age, square brackets, and then we're passing in 3, and then we're changing the value to 950. So when we come down to line 9, you can see that we are now printing out the value that is at index 3, and then you are going to see that it will change to 950. So once I run this code, you can see that 950 gets printed out. Now 950 gets printed out because in line 7 we had already modified the value of 950 of 90 to be 950. So that is how to create arrays in the C programming language. Now arrays are very useful as they are used to store large amounts of data. So for example, imagine I wanted to create a variable. Imagine I wanted to store these 4 values. Another approach to do it is to store each of them in different variables. I can come down and say int age 2, and I can also come down and say int age 3, and then I can equate all these ages to these other variables. But since there is a way to store all these values inside one variable, that is the best way to do it using arrays. So if you have any question, you can leave it in the comment section. Welcome to this section of this course. In this video, we are going to be talking about functions and how we can make use of them. So what exactly is a function? A function is just a block of code that does a specific task. So let's say, for example, you wanted to make a simple calculator. You could write a function for adding numbers, a function for subtracting, a function for dividing, and a function for multiplying. So a function basically is just a block of code or chunks of code that does one specific task. So now if we look at the screen right now, we can see this int main. We've kind of been using this in the past, like 12 videos, but this itself is a function. This is called the main function, and anytime we run our code, the main function always gets executed first. So we are going to see how we're going to understand how functions work a little bit more. So again, I said anytime you run your program, it is a main function that gets run first. So now I am going to teach you how to create your own function. So in order to create a function, you need to give C some parameters. So the first thing that you need to do is you need to specify what return type your function is going to give back. That is, anytime your function has finished running, what kind of data does your function return back? So we have to specify it, whether it's an integer, it's a char, whether it's a double. So we have to specify it before creating the function. So for now, we are not going to really talk about return types, but in the next video we're going to dig deep into it. So for now, we'll just create a function, and then the first return type we pass in is void. What that means is that our function isn't going to return anything. So it's just going to perform a task, but it's not returning anything. So what I'm going to say, what we need to do is we first need to specify the return type. Then we now need to create a name for the function. So I'm going to call it hello. And after typing in the name, just put curly brackets like put parentheses like that, and then curly brackets. So once you've done this, this is a function. Now the starting and ending of a function are denoted by this open and close curly brackets. The same thing for the main function, open and close curly brackets. So when you are exiting a function, it is at this point where the curly brackets closes. So now we've created a function called hello, and then let's just say we want this function to print something to the terminal. Like for example, let's just say we want the function to print my name is the Proton guy. So let's just say we want the function to print f my name is the Proton guy. Now I want you to take note of something. Once we run this code, you'll notice that nothing gets printed out in the terminal. Now why does nothing get printed out in the terminal? The reason why nothing gets printed out is because, remember in the beginning of this video, I said the only function that gets run anytime you run your code is the main function. So now the question that now comes up is, how do we run our hello function? Now we can run this function by doing what is called calling the function. So since the main function is the only function that runs anytime we run our program, what we now need to do is call this hello function inside the main function. So we do that by saying hello by saying hello, and then we put the curly brackets, the parentheses and the semicolon. So what this means is that we've created a function called hello, but it can't run by itself because the main function only runs. So what we're going to do is we're going to call this hello function right inside the main function. So once I run, let me clear the terminal. Once I run this code, I enlarging the terminal, you can see it's first giving an error, and then it's now printing my name is Proton Guy. So the error says, note, previous implicit declaration of hello was here. So what the error means is that, so first in our main function, we are trying to call this hello function. But remember that once C is runs this program, it runs it line by line. So when it gets to this point, it doesn't necessarily know where the hello function is, but it runs the code, right? But it doesn't necessarily know where the hello function is. That is why we are getting this error. So in order to clear that error, what we need to do is just copy this function that we have created and then paste it above the main function. So once we let me widen up the terminal. Once we run this code now, you can see that my name is the Proton Guy gets printed out and we have no errors. So that is how to create a function basically. And then you can write any sort of code in your function. Like I said earlier, you can create several functions to do several tasks like multiplication, addition, and all that. Now there's also something that we can do called passing in parameters. So let's say, for example, we didn't want to pass in the Proton Guy here, but we wanted to pass it in as a variable. Now I will show you how we can do it. So first we need to come into the parentheses of our hello function and we need to create a variable, and I'll say char name and I'll leave it like that. So what I'm trying to do is I am trying to create a parameter that can be passed into this function where we can access it in my printf function. So I'm going to show you how to do that now. So instead of saying my name is the Proton Guy, I'm just going to remove that and pass in %s, and I'll put a comma and just pass in name. So in essence, anytime we're now running this hello function, we need to pass in a parameter into the hello function so that the value can be used in this printf function. So I'm just going to pass in the Proton Guy. Now once I run this function, let me clear out the terminal. Once I run this function, you can see it prints out my name is the Proton Guy. It's able to do this because in the hello function we had declared that this function takes one parameter, which is a string or a string of characters, and then once we are taking in that parameter, we now want to print out my name is plus the parameter that has been passed into the function. Now we can also pass in like another parameter like age. So I could say int age, and then because it's now taking in two parameters, I'll have to come down and pass in the second parameter. So let's just say like 75. So inside this printf, I would say my name is the Proton Guy and I am %d years old. So I'm just going to come here. After passing in name, I'll pass in age. So I'm going to save this now and run this code in the terminal. So you can see that it now says my name is the Proton Guy and I am 75 years old. So what we have done now is we created a function called hello, and then the function takes in two parameters, name and age, and then it's now the function prints out the person's name and then how old the person is. So in order to run this hello function, we have to call the hello function inside the main function, and then we also have to pass in the parameters that are needed, that is the name and the age. If we do not pass in any parameters inside here, for example, let's run this code and see what error it gives us. So let's
let me enlarge this. You can see that it gives an error declared here. So it said error, too few arguments to function hello. So it's just trying to tell us that it expected 2 parameters or 2 arguments to be passed into the hello function, but none were passed in. So that is how to pass in parameters into a function in the C programming language. So let's just create a second function to, like, for example, do the square root of a number. So I'm going to say or double. So first, I want to create a function that performs the square root of a number and returns that value to us, or prints out that value. So first, we need to declare what kind of return type, or we don't need to specify that for now. In the next video, we are going to talk about return types. So first, I will create another function, and the return type will be void, and then the name of the function will be squ square underscore root and then in here it's just going to take in one value, which is an integer. So I'm going to pass in int num. So the function is taking in one parameter, which is an integer. So I'm just going to printf. Okay, in order to perform square root, we need to import the math.h function. So I'm going to say hashtag include math.h. So when we now want to perform the square root of this number, I'm going to say the square square root of %d is %f. So what I'm going to pass in first is num, because we're trying to say the square root of this number that has been passed in is comma %f. In here we're now going to pass in sqrt, and this sqrt is coming from the math.h function. So sqrt num, and then let's put our semicolon right there. So again, if we run this function isn't going to run. The only way to run is if we call this square root function inside the main function. So I'm going to call the square root function inside the main function right now, and I'm just going to say square root, and I'm going to pass in, for example, 25. So let's see how this runs. So let me just put a \n here, or not there. Let me put a \n here to space things out properly. And I'll enlarge in the terminal. So once I run this code right now, you can see that it first prints out my name is Proton Guy and I am 75 years old. That is coming from this first function, and then we pass in the parameters the Proton Guy and 75. So what it did is it first came here and saw that we are calling the hello function. So it came up to the hello function, passed in those parameters, and ran the printf function. It now came down to line 15 and saw that we are passing in the square root function. We are calling the square root function and we are passing in 25 as a parameter. So it now came to the square root function and passed in 25 here. And you can see the results in the terminal is the square root of 25 is 5.0. So basically that is just how to create different functions that perform specific tasks in your code. In this video, I am going to explain what return statements are, functions. So in the last video, we talked about functions, saw how we could create different functions. But what we didn't talk about was return type. Now, let's say, for example, you want to write a function to calculate percent, and you don't actually want to print out that value in main function. Let's say you in the function itself that calculates. Let's say you want to do some specific processing with that person's age. Now, how do we do this? What you can do is we can write a function called calculate age, and we can return that value to where it was called from. Now, the way you typically write functions that return something specific we first pass in the return type, then the name of the function. Then if it has parameters, we pass the parameter, then the curly bracket. So this is how we have been writing functions before. We said void, say hi, then we're just printing hi to print. Now, this void itself represents that our function called say hi isn't returning anything back to where it was called from. So what I mean is, if I call this say hi function, say hi, and I decide to run this program, it's just going to print out hi print, because we have told it to print hi out to the screen. As you, it's not actually returning anything, and we have specified that the function say hi does not return anything because the return type is void. But what if you want to, as you said before, calculate the age of a person? So first, we need to specify a return type. I'm going to say int because we want to return the age of that person. I'm going to say int calculate age, and in here we're just going to take in one parameter, which is the person's date of birth. I'm going to take in that parameter and say int date of birth IR. Now what do we want to do? We want to return the current year, which is 2023, minus date of birth. So what exactly does this do? We declared a function called calculate age, and we declared that the return type is an integer. So it means that anytime we're using the return statement, we always have to return something that is equal to the data type we had specified. So the return type has to be equal to what we are returning from the function. So we're just taking in a user's date of birth, and then we're saying return 2023 date of birth. So I will just call this function here and say calculate age. I will pass in, let's say, 1990 example. Now after calling this function, I'm going to run it, and it's just going to print out say hi. But if you notice, nothing happened. It didn't print out the person's age. That is because all we did was return person's age, which was calculated. We haven't actually done anything with the age which just recovered, which we had gotten from calculate. So how we can use this data is we can just write a print statement and say printf to %d years. And what we can now do is we can call that function called calculate age. So it's going to print out to you whatever this function returns. It's going to print that out years old. So if I save that and run it right now, you'll see that it is hi. First print hi from the say hi function, and it is 33 years old. So that is how we can use return types, calculate do different things. So the return type just basically specifies, okay, what is my function going to return back to where it was? And then when we want to return that actual, we just use the return keyword and we type whatever thing we want to return back where it was called. Now we can also write a different function just to show you how this works. We can call it char calculate grade. Now this is just going to take in an integer, or no, let's say floating point number. We're going to collect float exam grade, exam score. So what we are going to do is we are going to calculate what a user's grade is, or what a student's grade is, if based on what they scored. So if a student gets above 90, A, he gets below 90. If their score is between 90 and 80, if it is less than 90 but greater than 80. So let's write that. We're going to say if exam score greater than 90, then we are going to return. We're just going to return A. We're going to explain this. Then we're going to now say else if exam score is less than 90 and greater than, and exam score is greater than or equals to 80, then it means we're just going to return B. So now what we are simply doing here is we wrote a function called calculate grade, and it returns a character, a char data type. So we're also taking in a parameter which is of float, which is a float rather, and the name of the variable is exam score. So we want to say if the exam score is greater than 90, then we want to return A, that is students got A. We now want to say else if the score less than 90 and the score is greater than or equals to 80. That is, if the users or the student score falls between 80 and 90, then we want to return a B. So we are doing this because we are returning a B and an A because we specify that our function, which is calculate grade, returns a character data type. So now if we want to call it, we can just come down and say into printf, and then we're going to say your grade from exam is %C, because we're trying to print out the character. And then we're just going to call the calculate grade function. We're going to pass in, let's say we pass in 95. Our student is a very smart student. Just going to put this thing. So if I clear my terminal right now, I run this code. So it says, hi, at 33 years old, your grade from the exam is. So it says, hi, you are 33 years old and your grade from the exam is. So we can see now that the code is working well, and we created 3 functions. One which returns nothing, it just prints something to this. Second one which calculates a user's age, and it returns an integer data type. And the third one, a function which calculates a student's grade and it returns a character data type. If I entered something like 81, or let's say if I entered 80, for example, now I'm expecting that it prints B. So let's run it, and it says your grade from the exam is B. So you can see now that the functions that we wrote are working well. Everything we have written so far is good. So that is all we're going to talk about in this video: return function, return statement. In this section of the course, we are going to talk about conditionals, that is the if statements, else if statements, and else statements. So a conditional is basically a way of giving your program the ability to make certain decisions based on some kind of input, some kind of condition, or some kind of output. So let's say, for example, we wanted to write a C program that accepts 2 numbers and it determines which of the numbers is the largest one. So we can do that. The first thing that we are going to do is first create a function. Now the function is going to be the part that actually determines which of the 2 numbers is the largest. So since it's going to return an integer back to us when we call the function, we need to declare the return type to be int. Now I am going to name this function largest number. So I'm going to say largest underscore number. So the function is going to take in 2 parameters, that is 2 numbers. So we need to declare that this function is going to take in 2 parameters. So these numbers are going to be of the data type int. So I'm going to create the first parameter and name it num1. I'll say int num1, and then I'll say int num2. So after doing this, just create curly brackets and press enter. Now remember that if you had watched the last video, we need to kind of like register this function at the top so that we don't have any errors, because C might not be able to find this function when we call it in the main function. Right, so now we need to write the code that actually determines which number is the largest number. So I'm going to write a conditional right here. So I am going to say if open parenthesis num1 is greater than num2. Now open curly brackets. So let me explain what is happening in here. Anytime you want to write an if statement in C, you first have to write the if keyword, then open this parenthesis. Now inside this parenthesis is where you now actually pass in what condition you are trying to test, or basically what condition you are trying to test or check for. Now this right here, this angle bracket, is a logical operator. You have several logical operators. You have the greater than, you have the less than, and a whole lot more. Well, as we progress in this course, we're going to talk about more. So right now we are passing in the condition if num1 is greater than num2, and then we've opened this curly bracket. So inside this curly bracket is where the actual code that we want to execute if this condition is true is going to be in. So if this condition is true, that is if num1 is actually greater than num2, then we're just going to return num1 as the highest number. So we're simply going to say return num1. But what if num1 is not the largest number? It would mean that num2 is the largest number. So what we now need to do next is create an else block. So I'm going to say else, then open this curly bracket, and I'll say return turn return num2. So now let me explain what is going on in here. So first we created a conditional and if statement that checks if the first number is greater than the second number. Then if the first number is greater than the second number, we're returning it here. So obviously if the second number is greater, if the first number is less, it means the second number is greater. So that is why we have this else block. Now an else block is typically the last option in a conditional. That is the last conditional that will run if every other condition is not met. So if this condition right here is not met, that is if the second number is greater than the first number, it means the else block is going to run, and then the program is going to return num2. So after writing this conditional, the next thing we now actually need to do is call this function inside our main function. So to do that, I will just I'm just going to call the function right here, and I'll pass in two numbers. Let's first pass in 3 and 1. So okay, so after we pass in 3 and 1, we now actually need to print out the value. So instead of just calling it like this, I'm going to print out something to the screen. I'm going to say printf, and I'll say the largest number is %d, and after passing in %d, I'm just going to put a \n right there to create a new line, and in here I'm going to pass in largest number. So basically what I am doing is, okay, let's remove this semicolon. What I am doing is I am trying to print the largest number is %d, and in place of %d I am calling this largest number function, and I'm passing in two parameters, which are 3 and 1. So obviously, because we had already written a conditional, the function is going to check which of the numbers is the largest, and is going to return whatever number is the largest. So let's save this program right now and run it. So I think we're getting some kind of, okay, I didn't put a semicolon here. So let's run this again. So you can see that it prints out the largest number is 3, because 3 is the largest number. So let's say, for example, we changed here to be 9. Let's run that and see what happens. You can see the program gives us the largest number is 9. So using these conditionals, we have been able to determine which of these numbers is the largest. So you can imagine what kind of beautiful or awesome programs you can build using conditionals. Now we've written some code to actually check for we've written some code to determine which number is the largest out of two numbers. But what if we wanted to write a conditional that checks which number is largest out of 3 numbers. Now we can do that, and I'll show you how. We just need to update this largest number function right here. So after creating num2, I'm going to come and create another parameter, and I'll call it num3. So we now need to update this conditional. So instead of saying if num1 greater than num2, we're also going to add to it. We're going to say if num1 greater than num2 and num1 greater than num3 num3. So what exactly is this double AND operator? Now this is another kind of logical operator that acts as an AND. So what it does is it checks 2 conditions to see if those 2 conditions are true. Now if those 2 conditions are true, whatever code is inside the curly brackets is going to be run. So again, this is just the AND logical operator, and it checks if 2 conditions are true. If 2 or more conditions are true, it checks if all the conditions that you passed into this parentheses are true. So now we're saying if num1 greater than num2 and num1 greater than num3, we want you to return num1 as the largest number. So what if num1 isn't the largest number? What if num2 is the largest number? Instead of saying else if here, we can make use of the else if keyword. Now the else if keyword is another way of including more than one conditional in your program. That is, it's a way of telling your program, okay, if this first condition didn't or if this first condition wasn't satisfied, I want you to run this second condition. So I'm going to say else if, and then open parenthesis right here, else if num2 is greater than num1 and num2 is greater than num3. That is, if if the second number is greater than the first number and the second number is greater than the second number, obviously we're going to return the second number as the largest because the second number is greater than both of them. So at the end, we now need to put an else. That is, if the first number isn't the greatest or the second number isn't the greatest, obviously we know that the third number is going to be the greatest. So I'm going to say else, and I'll just simply say return num3. That is, if the first number and the second number are the greatest, obviously it means num3 is the greatest number. So to test that our program is working, I'm just going to pass in a second number here, like let's say 1. So let me clear the terminal and try to run this code. We are getting an error somewhere. Okay, let me widen the terminal, clear, and try to run again. Okay, we're getting a number from an error. Okay, the reason why we're getting this error is because at the top right here we declared only 2. Sorry, we declared only 2 here, but we declared 3 here, so that's why we're getting that error. So to solve this, just add num3 at the top, and that error should be fixed. So let me clear the terminal right now and try to run this code again. So you can see it gives us the largest number is 9, even though we passed in 3 values, 3, 9 and 1. Let's try to change this up now. Let's make this 4, and let's make this like 9, or no, let's make this 7. Let me clear the terminal and run this code. You can see it gives us the largest number is 7. So you can see our program has been able to determine which of the 3 numbers is the largest, and you can already start picturing what kind of mad, or sorry, permit my language, what kind of crazy programs you can build using conditionals. So that is what we're going to talk about today. And there's one last thing that I wanted to mention. the else block should always be the last block in every chain of conditionals. So what I mean is that after you write an else block, coming down to write another conditional like else if it's going to give you an error, because you already told C that else. So what that means basically is if every other condition at the top wasn't fulfilled, it simply means that I want you to run whatever is inside this else conditional. In this video, we are going to talk about operators. So operators are generally used in every programming language, but we are specifically going to talk about operators for the C programming language. And the first set of operators that we're going to talk about are the assignment operators. So the assignment operators help us just assign values to variables. So to give you an example now, this equal to sign right here is an assignment operator, because we're assigning 6 to be a value of num1, or in simpler terms, we're trying to say num1 equals 6, so the new value of num1 is 6 due to this operator, the equal to sign, which is an assignment operator. Now the next assignment operator that we are going to talk about is the minus equal to or plus equal to operator. Now what if we wanted to reduce the value of 4 by, let's say, 2? I could come down and say num2 minus equal to 2. So what I am saying here is that I want you to go to the num2 variable and reduce the value of whatever has been equated to num2 by 2. So if I print out num2 right now, you see that it says number 2 is 2. That is, the value has decreased from 4 to 2 because we have said minus equal to. So this is also saying num2 is equals to num2 minus 2. Now this is the exact same thing as saying num2 is equals to num2 minus 2. And if I run this, you see that it still says number 2 is 2. But to write it in a shorter way, we just say num2 minus equals to 2. Now we can also do the same thing for other arithmetic operators. We can say num2 is equals to num2 plus equals to 2. Now this is the same thing as saying add 2 to whatever the value of num2 is. And if we run this, you can see it says number 2 is 6 because it added 2 to 4 right here. Now we can do the same thing for multiplication. So I can say num2 times equals to 2. Now since 2 times 4 is 8, it should give us 8 right back. So you can see it prints out num2 is 8. And then we can do the same for division also. Num2 / equal to 2. And once we run this, you can see it gives us 2 because it's performed the division of 4 divided by 2. So that is those are some of the basic operators that we have, some of the basic assignment operators that we have in the C programming language. Now the next set of operators that we're going to be talking about are the comparison operators. So these operators are used to compare two values or two or more values, basically, to see whether they match or to see which quantity is larger or which quantity is more. So the main thing they do is they just compare two or more values of variables together. So the first comparison operator that I'm going to be talking about is the double equal to. That is double equal to like this. Now this is used to check if two values or two variables are equal. So for example, I can write a conditional right here and I can check if the value of num1 is equal to the value of num2. Inside here I would say if num1 is equal to num2, that is, I want to check if whatever value that is here is equal to the value that is here. So if num1 is supposed to be num_1, so if num1 is equal to num2, I want you to print out they are equal. So I'm going to put a semicolon here. Then if they aren't equal, I'm going to write an else block right here, and I want you to print out they are not equal. So let's run this code now to see what it gives us. You can see it prints out they are not equal. So basically what the program did was that it took num1 and it took num2 and it checks if their values were equal to each other. That is what the double equal to operator is used for. It's just used to check if two values are equal to the same. If two values are the same thing. So the next comparison operator we're going to talk about is a not equal to. That is, if we want to check if the value of num1 is not equals to num2, what are we going to do? We say not equals to by first putting an exclamation mark and an equal to symbol. So these together form the not equal to comparison operator. So if we want to check now if num1 is not equals to num2, we can now say if num1 not equal to num2, we will say they are not equal. But if num1 is equals to num2, then we're going to say they are equal. So let's run this in the terminal right now. So you see that it gives us they are not equal because obviously 6 is not equals to 4. Now to go over it again, this operator is just used to check. It's used to check if two operators are not equal to each other. So if they are not equal to each other, it means this condition has passed, has been fulfilled. Hence, this print will work. But if these two conditions are equal to, if these two values rather are equal to each other, it means that this print is going to work. This else block is going to work, and it's going to print out they are equal. So that is that about the not equal to comparison operator. Now the next one that we're going to talk about they are the I will kind of call them magnitude comparison operators. That is the angle brackets. So we can check to see if num1 is greater than num2, and we can also check to see if num1 is less than num2. Another thing that we can also check is to see if num1 is greater than or equal to num2, and we can also check if num1 is less than or equal to num2. So these are all just basic operations that we can carry out to see if a number is greater than the other number. So let's say if num1 is greater than or equal to num2, we can print out, or let's remove the equal to part. So if num1 is greater than or equal to num2, we can say num1 is greater. Num1 is greater. Then else, we're now going to type in num2 is greater. So let's clear this right now and run. So since num1 is 6, it says the first number is greater, which is true because we're written a conditional in here to check if the first number is greater than the second number, then print num1 is greater. Now so that is that about comparison operators. We talked about the double equal to sign, which checks if two values or two variables are equal to each other. We talked about the not equal to, which helps us check if two values are not equal to each other. Then we talked about the magnitude I will call them the magnitude comparison operators because they help us check if a value is greater than another value, or if a value is less than another value, or if they are less than and or equal to some specific value, or less than or greater than or equal to some specific value. So that's that about the comparison operators. Now the last set of operators that we're going to be talking about are very special, and they are called the logical operators. Now the logical operators just help us to check for more things between several values. So for example, let's say we wanted to check if num1 or num2 are both greater than, let's say, 2, or no, if num1 and num2 are both greater than 5. How exactly are we going to write that? Now the way an OR logical operator works is that all it needs is for one of the conditions that is checking for to be true. Now I'm going to show you exactly what I mean by that. So let's check to see if any of the numbers, that is num1 and num2, if any of them are greater than 5. So I'm going to write a conditional here, and I'm going to say if open bracket num1 is greater than 5, or num2 greater than 5, and I'm going to open parentheses and printf yes, one of the values values is greater than 5. Now let me explain what is going on inside this parenthesis right here. So we're checking if num1 is greater than 5 and num2 is greater than 5. Sorry, if num1 is greater than 5 or num2 is greater than 5. So if we want to create an OR logical operator in the C programming language, we use the pipe key. You have to create 2 pipe keys, or you have to type pipe twice, I mean. So this represents OR in C. Now what it essentially does is that it checks 2 conditions, the conditions that have been given to it inside the parentheses, and as long as one of the conditions is true, it's going to run whatever is inside that conditional. So all it takes to run this conditional is for one of the conditions inside to be true. So let's clear the terminal right now and run this code. I am getting an error somewhere. print. I didn't put my t. Okay, so let's run this code right now. So you can see it prints out yes, one of the values is greater than 5. Now it was able to determine that because it's first checked, is num1 greater than 5? Obviously num1 is 4, so it isn't greater than 5. So it's now said, or is num2 greater than 5? Since num2 is 6, it means that yes, num2 is greater than 5. So this condition is satisfied. Now we can add as many values as we want in here. For example, I can create another variable and call it int num3, and I will equate that to let's say 9. And I can also come here and create another OR operator, and I can say or num3 greater than 5. Now this is also okay. If I change value of num1 to, like, let's say 3, now the only value that is greater than 5 is 9. So once we run this program, it should print yes, one of the values is greater than 5. So let's run it. It's giving an error. Let me clear the terminal and run this again. So you can see that it prints out yes, one of the values is greater than 5, because this last condition right here was true. And remember, I said all an OR operator needs is for one of the conditions that have been passed in to be true. Now that's that about the OR operator. The next operator we're going to talk about is the AND operator. Now we talked about this in the last video, but we're just going to shed more light on it in this video. Now for the AND operator, it's just like the OR operator, but it requires every single condition inside the parentheses to be true. So the way we create the AND operator is we use the double AND symbol. So we can create that here. So here we're going to say if num1 greater than 5 and num2 greater than 5 and num3 greater than 5. So what it just simply means is we're trying to check if all the numbers are greater than 5. Now an AND operator will only be fulfilled again if all the conditions inside the parentheses are fulfilled. So if let me just add an else block here, sorry, and I'll say else printf and I'll print out all the values are not 5. So if I run this code right now in the terminal, what do you notice? It prints out all the values are not 5. All the values were not 5 because all the conditions were not met. But if I all the values are not greater than 5. This is supposed to be are not greater than 5. Now it's printed that because all the values right here are not greater than 5. But if I were to change this to like 8 and change the second one to like 67, for example, when I clear the terminal and run this, you'll see that it prints out yes, all the values is greater than 5. This was a mistake. This is supposed to be yes, all of the values are greater than 5. So right now you can see that the AND operator requires all the conditions that it is tested with to be true, whereas the OR operator only requires one value to be true. So these are the logical operators that we are going to talk about today, or basically these are all the operators that we're going to talk about in this video. Hello and welcome to this YouTube video. In this video we're going to talk about switch statement. So what exactly is a switch? A switch statement is just a way of writing if condition. It's a way of writing if conditions, but it's a different way. But in this case, we are going to be comparing one specific value to multiple possible outcomes. So I'm going to show you how exactly this is. So let's say, for example, we want to write a program that is going to ask a user to enter from 1 to 7, and then depending on whatever they pick, it's going to map that number to a specific day. So it means if they enter 1, it's Sunday. They enter Tuesday. They enter 3, it's Wednesday, and like that. So let's start. So we're going to say int day, and then we're going to ask the user, we're going to say printf enter a day or enter a number from 1 to 7. Just going to put a colon here. So since we want to collect these inputs from the user, we're going to use scanf, and then I'm going to put here and say %d and %day. So we're just here asking the user to input a number from 1 to 7. So here we're now going to use a switch statement. So we're going to say switch, and then we're going to pass in day. So what we want to do is that we want to compare day. We want to compare whatever the user has entered, different cases, to see if whatever user entered matches a specific case. So the way switch statements work is that you first type switch, and in here you pass in the value that you are trying to compare with other cases. Then you put a curly bracket. Now you are going to see what I mean by cases. So when I press enter, we're going to type case 1. But before I continue typing, I want to explain. So I said that we're going to be comparing a specific value to multiple cases. So we want to say that in the case where what the user enters from this scanf is 1, we want to execute some code below. So I'm just going to say in the case where what the user enters is 1, I want to printf. I'll say it's Monday, and then I'm just going to put a semicolon there, and I'm going to pass in another keyword called break. So what break means is that we just want to break out of the switch case. We want to stop entirely and leave the switch case. That's what break means. So the user just enters a number, and then we're trying to compare that number which was stored in. We're trying to compare it to say, okay, if what the user entered is 1, then print it's Monday, then break out of this. Now what if it's 2? I'm also going to say case 2, and I'm going to copy this. I'm going to say it's Tuesday, TUES. I'm just going to copy this and do it to 7. Now, if you notice, you can't repeat numbers because we already have 2 here. So this has to be a different value. This is going to be 3, going to be 4. So I'm going to say it's Tuesday, it's Wednesday. And here I'm going to say it's Thursday. Right? And then I'm going to do one more. Sorry, I'm going to do one more, which is 5. And then I'm going to say it's Friday. So now we've written this switch statement. So what we now need to do is we need to write one more final. So the last one serves as like a default. So I'm going to explain what this is. Default, I'm going to say printf, you entered an invalid number. So what does this mean? You know, in if statements, we have the condition inside the if block, and then we have multiple else if to check for a specific statement. So we can look at the cases as the else ifs in the if statements condition, and then we can look at the default as an else block in the if conditions. So the default means if all these cases were not satisfied, that is, if what the user entered wasn't 1, wasn't 2, wasn't 3, wasn't 4, or wasn't 5, then it means that a default, it means that it's going to fall to default value, and it's going to print you have entered an invalid number. So since we stopped at 5, let's just say enter a number from 1 to 5. So if a user enters a number that is not in the range of 1 to 5, then it's going to say you have entered an invalid number. So let's try to run this code right now. And then the program asks us enter a number from 1 to 5. If we enter 0, it's going to say you have entered an invalid number, because this the C compiler when we ran the program, it went through each case. Case 1, it checked, did the user enter 1? No. Then it broke out. Did the user enter 2? No. 3? No. 4? No. 5? Then it came to the default value and printed you have entered invalid number. So let's say if I run it again, just like to run this again. It says enter a number from 1 to 5. So I'm just going to type 5, and then it says it's Friday. So if I run this again and I say like 2, it says it's Tuesday. So that is basically how switch statements work. They are just like another way of making comparisons. So you don't have to use an if else conditional or if else block. You can decide to use a switch statement if you are going to be comparing one specific value to multiple possible outcomes that value can have. So we're saying if the user entered 1 or 2, 3, 4, or 5, then we have possible solutions to each of those cases. I'm just going to put a break here. Forgot about that. So that is how switch statements work. So we have the switch keyword, then we pass in what value we're trying to compare, and then we put curly brackets and write the cases, and the cases represents the possible outcomes that value can have. Hi and welcome to this video. In this video, we are going to talk about structs in the C programming language. So I would just like to explain what structs are. So structs are basically, or structs is basically like a container that lets you group different data types together under like a label. And structs are short for structures. So structs are useful, for example, when you want to represent an object that has multiple attributes. So let's say, for example, you want to model a human being. A human being has a name, has an age, has a gender, and like occupation, for example. So it's just used to model like objects have attributes. So in this example, we are going to be creating a struct called human, and we are going to be modeling as something of a human. So let's say struct stru struct human. Now, what exactly does a human have? A human has a person has a name. I'm going to say char name, and then let's just make this 50. And a human being also has an age. I'm going to say int age. Let's also add something like occupation, for example. So I'm going to say string. Sorry, not string. I'm going to say char occupation. and I'm just going to make this 50 also. So right now we have name, age, occupation. So this is all we're going to be modeling concerning concerning a human being. So if we would like to create an object of a human being struct, what we first do is say struct, then we specify what object we are trying to create or what struct we are trying to create. So I'm going to say human, and then we need to give this struct a name. I'm going to say person 1. So what we can now come down and do, we can define the attributes for this person that we had just created, because we had already specified attributes that human class has. So we can see that the human class has a name, age, and occupation. So what we are going to do is we are going to give those attributes person 1 I just created, because person 1 is an object struct human. So we can now come down and say person 1, we can say person 1 dot name equals to we can say Jimmy. Now note that if we try to do this, it's going to give an error, because we can't just say person 1 dot name is equals to Jimmy, because this is an array of characters, and we can't just say it's equals to that. So what we need to do is we need to use a library. We need to import a library. Now we're going to say hashtag include string h. Now I am going to explain why we are doing this, but just follow with me. So I'm going to say strcpy. Now this strcpy function comes from string.h library, which we had just. I'm going to say strcpy person1.name. Then I'm going to say Jimmy. So what we are doing here is that we are trying to copy Jimmy and then put it or append it to array person1.name. Because the name attribute an array of characters. So we can't just say the name is equals to Jimmy. We have to copy those characters into the array. That is why we're using strcpy. So the human also has an age. I'm going to say person1.age equals to, let's say, 28, for example. And then the human also has an occupation. So I'm going to say person1.occupation equals to, and again, it's an array of characters. So we can't just say is equals to software developer or something. So what we have to do is we have to use the strcpy function. We're going to say strcpy person1.occupation, and we're going to pass in software developer. Now what we have just done is that we have modeled a human being using a struct. Now this can have a lot of attributes, like for example, we can say int gender, where 1 represents male, 0 represents female, male. So what we can now say here is person1 person1.gender equals to, let's say, 0. That makes this person a woman, but Jimmy is a man's name, masculine name. So I'm just going to put 1. So now we have modeled the struct, or we have modeled a human being using a struct, and the human being has attributes name, age, occupation, and gender. So how do we now actually make use of all this data? Now we can make use of this data in various ways. For example, I can print out this person's data, but I'm going to create a function for that. So let's just make use of all the knowledge that we've gained so far in this course, in this programming course. So I'm going to say void display person data. Now this is going to pass in, this is going to collect a struct of human. So it means that we have to pass in a human struct into this function. What I'm going to do is I'm just going to printf, and I am going to say name is going to say %c, %C because we are, oh no, sorry, %S because we want to print out name of this person and it's a character array. So we need to use %S. So I'm going to say name colon %S. Now put a comma there and I'll say age colon %D. And after that, I'll put a comma and say occupation %S. And then I'll say comma gender %D also. So I'm just going to first pass in, we have to pass in the person's name. So I'm going to say struct human person. Yeah, I'm just going to say struct human person because we actually need to create the human class, human object. So I'm going to say person dot name, and I have to pass in person dot age. I have to pass in person dot occupation, and the last thing is person dot gender. I'm just going to put a semicolon there. So what we now have to do is we have to call this display person data function in our main function, and we are going to pass in person1. So what we've done now is we've created function, or we've created a person struct which models a human being, and we've assigned the person's name, age, occupation, and the gender. Then we created a different function which is called display person data, and this function accepts a struct. So what we're now doing is we are trying to print out data, this particular person that we have just passed. So we're saying the name is that, age is %D, occupation is %S, gender is %, and then we're just calling details of the struct. We can say person1.name is going to get the name, person1.age is going to get the name. So let's run this code now and see how well it works. I'm going to hit run, and it says name Jimmy, age 28, occupation software developer, gender is 1, which stands for male. So right now you can see that we have successfully modeled a human being using a struct in C, and then we've been able to assign persons, that human being's name, age, occupation, and gender. Now what this means is that it's almost a way of doing object-oriented programming, but not specific, because it was in C++ that object-oriented programming was. But if you would like to create objects in a way that has, or if you would like to create an object that has multiple attributes, you can use a struct and then can write as many attributes as you want inside that struct. So that's what we have done here. We created a struct of human and we assigned values to that struct. And we assigned attributes to that struct. And then we came to the main function and assigned values to those attributes struct. And then we created a function called display person data. And we passed in the object of that struct that we have, which is person1 here. We could have done the exact same thing here and said we could have printed out everything that we did here inside the main function. But I just wanted to create a different function called display person data to help us do that. And that function takes in struct, and the struct that it takes in is a human object, human struct object takes in. And then we're saying person because person is going to represent the variable human struct object, just like how we did person1 here. And then we're just trying to print out the values of that struct. Then person.name, person.age, person.occupation, person.gender. Welcome to this YouTube video. Today we are going to talk about while loops in a C programming language. So imagine a scenario where you want to repeat a certain block of code as long as a particular condition holds true. That's where while loops come into play. It's like having your code on repeat until a specific condition is met. So we're just going to constantly repeat a specific block of code while a condition holds true, while a condition is met. So right here on my screen right now, I have a variable called num, and it's equated to a value of 50. So let's say, for example, we want to print out all the values less than 50. That will be from like 0 to 49. We can use a while loop for that. So I'm just going to write the structure of a while loop and explain how it goes. I'm going to say while, I'm going to just type the while, then open a parenthesis, then open my curly bracket.
So let's explain what is going on here. This is a basic structure of a while loop. We have the while keyword, we have the parentheses. Now inside this parentheses is where we write the condition that we are trying to check. That is, if that condition holds true, then the code block inside the while loop is going to run. But if it doesn't hold true, then it's going to exit out of the while loop. So right now we want to write a while loop that prints out all the values that are less than 50. So what we're now going to say is we're going to say while num is greater than 0. And what we're now simply going to do is say num minus minus. Now, why are we doing this? What we're saying is while the value of 50 is while the value of num is greater than 0, it means that we want to print out all the values constantly. So what we need to do now here is we need to print it out first. We need to print f, and we'll say %d because it's a number that we are trying to print out. And then I'm going to just pass in num. So what we're simply doing here is we're checking while number is greater than 0. Is number greater than 0? Yes, it's currently 50. Then we're going to print out 50. Then we're going to decrement the value of num. So at this point, num is now going to become 49. Then it's going to come and check this while loop again. Is 49 greater than 0? Yes. It's going to run the code block. So I'm just going to put a line break here to show you how it looks like when we run it in the terminal. So I'm just going to come here and run this block of code right now, and it should print 0 to 50 right now in the terminal. Okay, so as you can see, it's printed 1 to 50, or from 50 to 1, and you can see that it stopped at 1. So if I said while num is greater than or equals to 0, if I run that now, it should print from 50 0. So you can see that we used a while loop in order to print out all the values less than 60. It's just continuously ran this code block that is inside the while loop while this condition held true. Now, if I remove this num minus minus, for example, I want you to take note of what will happen. Once I press play, it's just going to continue printing 50 for eternity, because all we said was while num is greater than or equals to 0, then print the value of num. So it's always good to take notes that in a while loop you could have a bug that could make it run forever. So this num minus minus is kind of like the line that helps us check, that helps us keep track of this to prevent the loop from running forever. So that is what a while loop does basically. It just helps us repeat a specific code block while a condition holds true. Now we are going to work on a very cool guessing game, and we're going to make use of while loops. We're going to make use of a while loop and conditionals to build this guessing game. So let's move on to the next step. So it's just going to be an explanation of what you could do with a while loop, and you could do a whole lot more. And generally in programming, there are going to be a lot of things that you would like to redo over and over again until a certain condition is met. So that is why while loops are important. All right, so let's build the guessing game. So let me just explain what it's going to be. So imagine like we're just going to create a basic program that simulates a guessing game. So the user is going to guess a secret number that we're going to specify our code, and then we're going to keep asking the user until they get it correctly. Now also note that the user will have a specific number of attempts that they can try, so that they don't just keep guessing forever. So let's say we're going to set it to 3 guesses. So if they don't guess the number in 3 guesses, it means that they have lost the game. So what I would first like to do at the top is that I would like to declare some certain variables. So I'm going to first create the first variable, and it's going to be called guess. So this guess is going to be assigned to whatever the user has guessed in the we're going to ask the user, and it's going to be whatever number the user guesses. Now the next one we're going to create is attempt.
So this is just going to help us track the number of attempts that a user has done. So we're just going to equate this to 0, because when the user first starts, it's going to, the number of attempts is going to be 0. Then something else that we need to specify is the number of attempts that a user can have. So we're going to create one and say int max attempt, and let's set that to 3, because we only want a user to be able to guess 3 times. Now the last thing that we need to actually now specify is a random number. So let's just say we want our random number to, or our secret number, let's say we want it to be like 10, for example. So right now we have all the variables that we need. Let's now proceed to write the code that will actually run this guessing game. So first, we would like to print to the user that they should select we would like to print to user that welcome to the guessing game. Then we're going to write the for loop. I'm going to say printf. I'm going to say welcome to our guessing game, and I'll just put a new line here. Then the next thing that we're going to do is we now need to write a for loop. Now the logic behind our code is that in the for loop, we're going to say while the number of attempts is less than the max attempt, then we're going to write some code that is going to ask the user to enter whatever they think the number is, to enter their guess, because we want to restrict the number of attempts that a user has. I'm going to say while attempt is less than max attempt. That is, while the number of tries that the user has done is less than the maximum number that they can do. So we're going to run this code inside the while loop. So what we want to do first is that we want to ask the user to enter a number that is between 1 and 100. I'm going to say printf enter number between 1 and 100. And then what I will now do is I'm going to use a scanf to collect the user input. I'm going to say scanf, and in here we're just going to collect the user's input. So I'm going to say %d, because we're trying to collect an integer, and I will say %, yes, because we want to store whatever the user has entered in the guess variable. Now after we've collected that, what we now need to do is we need to write a few if statements. So we want to say if our guess is equals to secret number, that is, if whatever the user has guessed is equals to secret number, then what do we now want to do? We just want to printf and say that congratulations, you passed this, you have guessed the secret number. You have guessed a secret number. Now what we now need to do next is that we need to break. Now let me just explain what this is. Now the break is just another keyword that will help us leave while loop. So if like the user guesses the secret number on the first try, obviously it means that the user is going to have 2 more attempts. So what we now need to do is, instead of having the program run two more times, we're just going to break out of the while loop, because the user had already guessed it right on the first try, or it could be on the second try. So it's just a way of helping us ensure that when the user has gotten the number correctly, it breaks out of the while loop and it prints out, informs the user that they have gotten it correctly, and it breaks out of the while loop. Now what we now need to do is we need to create an else, and we're just going to print out a message saying wrong guess, try again. I'm going to say printf, and I'm going to say I'm going to type wrong guess, then we'll tell the user to try again. We'll create a new line here. So after doing all this, what we now need to do is we need to increment the number of attempts that this user has. So we're going to say attempt plus plus. Now also note that this is the same as saying attempt is equals to attempt plus 1. So we can use any one we want, but attempt plus plus just seems shorter, but we can also leave it this way. Now what we simply need to do is we will now come down outside the while loop, and then we're going to say if attempt, sorry, writing Python, if attempt is equals to max attempt. That is, once the user has guessed 3 times, it's going to break out of this loop. And after it has broken out of this loop, we now want to write an if statement that's going to inform the user that sorry, you have used all the attempts that you could take. So I'm just going to print out a message and say printf, you have reached the maximum number of attempts. I'll just create a new line right there. So this should be all the code we need to write in order to make this work. So let's go over it again. We have 4 variables. We have a secret number which is specified in our code. We have the guess which the user is going to impute. We have the number of attempts that the user has taken. We have the maximum number of attempts that any user can have. And we now want to print out to the user, welcome to our guessing game. And we have a while loop right here that checks while the number of attempts that the user has taken is less than the maximum number of attempts that any user can take. We want to now ask the user, okay, enter a number between 1 and 100. After this has been printed out, the user enters the number right here. And then we now write 2 conditions to check. If the guess is equals to the secret number, it means that the user has guessed the number. So we're printing out congratulations, you have guessed the secret number. And then we are breaking out of the while loop. Then if the user guessed it wrong, then obviously we want to just print out a message saying wrong guess, try again. Then we are going to increment the number of attempts by 1, because after this process, it means that the user had already attempted once. So once that is done, we now leave the for loop. So the only way we can break out of this for loop and this while loop, the only way we can break out of this while loop is if the user guesses this correctly, or if the user has used up all the attempts that they can have. That is when this while loop can be broken out of. Then once that condition has been met, or once the while loop has been broken out of, this condition is now run. If the attempt is equals to the max number of attempts, means that we have reached the maximum number of attempts. So what we now need to do right now is run this code, see how well it works. So I'm going to run it right now. Run this. So once I run this, okay, let me just clear out my screen right now. So once I run this, it's going to ask me, it's going to say welcome to our guessing game, enter a number between 1 and 100. So let's say I enter 1, it says wrong guess, try again. If I enter 2, it says wrong guess, try again. And if I enter a wrong number once more, it's going to say wrong guess, try again, but it now prints out you have reached the maximum number of attempts, and then the game ends. So it means that once we've tried 3 times, the game is going to end. So let's now say, for example, I enter the correct number, or the wrong number the first time, the wrong number the second time, and I enter the correct number the last time. So let's say I enter 10. It's going to say congratulations, you have guessed the secret number, and then the program ends. So that is how this while loops basically run. While the attempt inside the parentheses holds true, it's just going to execute whatever code block is inside whatever code block it contains. That is how while loops run. In the next video, we're going to talk about do while loops. Thank you for watching this video, and I will see you in the next one. Hi and welcome to this YouTube video. So in this video, we're going to talk about the do while loop. Now, the do while loop is very similar to while loop, and you will rarely be using it in programming. But the difference between the do while loop and the while loop is that the condition is checked last and the operation is run first. So if we look at the previous video example, anytime a while loop is about to be run, the condition is checked first and then the code block is run secondly. But in a do while loop, what happens is that the code snippet inside the while loop is run first and then the condition is checked last. So I'm just going to give an example in order to explain what I mean by this. So let's say, for example, we want to ask a user to enter a positive number, and we're going to continue asking the user to enter a positive number while the number that they enter is less than 0. Is less than 0. So what we're going to do first is that we're going to create a variable, and then we're going to just call it num. So what we now need to do is we're going to write the do while loop right now. So we're going to say do, and then we're going to open this curly braces like this, and we're going to print out enter a positive number. Enter a positive number. And then after this, I'm just going to use the scanf to collect the number from the user. So I'm going to say %d and %d comma and %num, because we're trying to assign the whatever the user enters num a variable. Now the next thing that we now need to do is we need to write the condition, and we need to say while num is less than or equals to 0. Now let's explain what exactly is happening here. So we said do printf enter a positive number, and then we collect the user from the user, and then we say while the number is less than or equals to 0. So it means that while the user enters any number that is less than, or instead of less than or equals to 0, let's remove the equals to. So while the user enters any number that is less than 0, we want to perform this operation. So the only difference between a while loop and a do while loop is that the operation is performed first, then the condition is checked later. So what we are now simply going to do at the end is we're going to say printf you entered %d. I'm going to put a comma and pass in num right there. So if we run this code right now in the terminal to see how it works, now you are going to see that it first prints out enter a positive number. I'm going to enter like -4, for example, and you see that when I enter -4, it's asking me again to enter a positive number. If I say -5, it says the same thing. -200, it says the same thing. But the moment I enter a positive number like 1, it prints out you entered 1 and the program ends. So that's basically what a do while loop does. It performs the operation first, then it checks the condition after. So this is just like a very simple example where we are asking the user to input a number, and then we check if the number is less than 0. And if it is less than 0, it goes back to this do block and it executes it. So we're saying do enter the number while the number is less than 0. So thank you for watching this video, guys, and if you have any question, don't hesitate to leave it in the comment section and I will reply you. In this video, we're going to talk about for loops. So in the last video, if you had watched it, we talked about while loops and how we could apply them. So on the screen right now, I have a very simple while loop. Now what this while loop does is that we have I initialized at the top, and it sets to a value of 10. And then the condition for the while loop is that while I is greater than 0, we want to print the value of I, then decrements the value of I. So it's just going to print from 10 down to 1. So right now, it has printed out to the terminal from 10 to 1. So we did this using a while loop. Now let's now see how we will do the exact same thing using a for loop. So I'm going to write the for loop first, then I'm going to explain the structure and exactly what it is doing. I'm going to first say write the code for, and I'll create the parentheses, then I'll put my curly brackets. So it is inside the parentheses where we're going to write the condition that we want to check or that we want to run. I'm going to say for int I is equals to 10, and I'll put a semicolon. I'll say while I is greater than 0, then I'm going to say I minus minus. So what do I want to do? I want to print the value of I. So what okay, so this is in I. So what we've done here is that we've written a for loop that's going to print value of 10 to 1. So let me explain the structure of a for loop. Now, in the structure of a for loop inside the parentheses, it is usually broken down into 3 parts. The first part is usually the initialization. So for example, here now we said for int I is equals to 10. So we initialize that, okay, I is set to a value of 10. Then the next part is usually the condition that we are trying to check. So the condition right here is I greater than 10, greater than 0, I mean. Then the last section is usually the decrement or the increment. So right now, we are now decrementing the value of I. So to further explain it, when we started the for loop, we said, okay, let's set the value of I to 10, then we put a semicolon. Then we want to say, we want to run this for loop while I is greater than 0. So I'm saying while, but it's not really referencing the while loop. It's just a way of explaining it. So we have that I is equals to 10, and while I is greater than 0, we want to decrement the value of I. So once we run this now, it should also print out value of 10 to 1. So you can see that it also prints value of 10 to 1. So we just initialize that, okay, I is equals to 10, and then we want to say while I is greater than 0, I minus minus. So this condition is, this for loop is always going to run while the condition that we specified is true. So the code block inside the for loop, I mean, is always going to run while the condition that was specified in the for loop true. So that is basically what for loop is. Now, for loops are quite powerful because we could also use it to iterate over something. So I'm going to bring in an array, for example, which I have here. So I'm going to replace this commented out code with the actual array. So let's say, for example, we want to print out all the values of this array. So what we can do is, we know that each value in the array has a specific index, and usually the arrays are in items in an array have specific indexes, and the starting index is usually 0, and it goes to 0, 1, 2, 3, 4, 5, 6. So if we would like to print 3 out, it's going to be at int 3. So now let me show you exactly how this is going to work. So there are how many items in the list? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 items in the list. So we're going to write a new for loop to print out all the items in this array. So I'm going to say for int I is equals to 0, I less than 8, then I'm going to say I plus plus. So let me explain what this is right now. So we said for int I is equals to 0. Then so we're going to start from the 0th index, which is going to be this first item right here, which is this item right here. And then we want to do this, we want to loop run this condition 8 times. So it's going to start from 0 and it's going to stop at 7. So it's going to run 8 times, and then for each time we increment, for each time we run the loop, we want to increment the value of. So now that we're looping through from 0 to 7, what we now want to do is we want to printf. We're going to printf, and in here I'm going to say it's nd because we're going to print out an integer, and then I'm going to say numbers of I. So by saying numbers of I, we are trying to access the specific index of that item using value of I. So using this for loop, we should be able to print out all the values inside this I. I'm just going to put a \n here, and once I run this code, it should give us the values of I. So it prints from 0 to 7. Now this could be different characters like 3, 4, 5, 6, 7, 8, 12, 45. So this is 1, 2, 3, 4, 5, 6, 7, 8. All right. So once I clear my terminal and also run this, it should print out those values. So it prints 3, 3, 5, 6, 7, 8, 12, 45. So that is how we can use a for loop to look through an array. Now this is very helpful because let's say we are tasked to do something concerning arrays or something else. We could definitely use a for loop to look through all the items in the array, print it out. So if you have any question in the concerning this video, please leave a question in the comment section and I am going to reply you. So to just briefly go over it again, we have an array of numbers of integer values, and then we have a for loop that loops from 0th index to the 7th index, because we said for int I is equals to 0 while I is less than 8, I plus plus. So it's going to loop from 0, 1, 2, 3, 4, 5, 6, 7, and then using the value of I, we are going to grab the whatever value belongs to this specific I index in the numbers array. So when I is 0, it's going to come to the array and grab 3 and print it out. When I is 1, it's going to come, grab 3, print it out. When I is 2, it's going to go grab 5, because we're passing in 2 here. It's going to be like we're passing in 2 into the array. It's going to grab 5. So that is how this section works. If you have any question, please don't hesitate to leave a comment in the comment section. I will reply. Hi and welcome to this YouTube video. In this video, I'm going to explain what two-dimensional arrays are, or 2D arrays are in C. So let's just picture a table or a grid or a matrix, right? That is essentially what a 2D array is. It's like having rows and columns that organize data neatly. So we have rows and we have columns in a matrix. Now, in order to model this kind of structure, we need 2D arrays. Now, previously in this course, we talked about one-dimensional arrays, which is like, for example, this. We have an array of integer values, which is called num, and it can store 10 items. Now, what if we wanted to create like almost like a matrix type of representation, where we could not only store specific where we could not only store like one-dimensional items, like just a list of numbers? What if we wanted to store also a list of arrays in a matrix manner? Now, that is what 2D arrays are, and it's just a way of like modeling a matrix in your code in C. So in order to do just that, we are going to need to create two square brackets. Now, this first square bracket is going to represent the rows, the number of rows that this two-dimensional array can have. That is this first row, this second row, and this third row. And then the second square bracket right here is going to represent the number of columns that this array can have. So the way you can think about it, the first square bracket is going to represent the number of items that can be stored in this array. Now, the second square bracket is going to represent the number of items that can be stored in elements of the original array. That is, the first one stores the number of elements as a whole that can be stored in the array, and this is 1, 2, 3. Then the second square bracket represents the number of items that can be stored in each element in that array. So let's model this example right here. So we see that we have 3 rows and 3 columns. So that is exactly what we are going to do. So we're going to say 3 there, and we're going to say 3 here. Now, what we now need to do is that we need to equate this to our curly brackets. Now, I want you to think of, let me just indent this in a way that will make it look proper. Now, I want you to think of it as a matrix right here. So what we are now simply going to do is that we are going to create another curly bracket inside this matrix. I'm going to come here and create another curly bracket. So the first item is 1, 2, 3. I'm going to say 1, 2, 3. Then the second one is 4, 5, 6. So I'm going to say 4, 5, 6. And then the last one is 7, 8, 9. So let me just push this in here. So right now, it's almost like we have modeled this specific two-dimensional array inside our code, inside C programming. Now, before, in order to access a specific item inside a one-dimensional array, all we had to do was use the specific index that we needed. But in order to access like a specific item inside a 2D array, you need two indexes. You need the index of the first item to get the row, whatever row it is in. Then you need the index of the second square brackets to get what column it is. So for example, if we wanted to print out 1 right here, we would need to access whatever row and whatever column it is at. So if I wanted to print it out, I would say printf, and I'll say %d, and then what I need to do is I need to print out 1, and then we know that this 1 is at index 0 of the first item and index 0 of the second square bracket. I mean, because indexing starts from 0, it means that the first column, this means that the first row in this matrix is this first row. So we're going to grab this first row, and we now need to also grab the column. Since the second square bracket represents the columns of the matrix, we're going to grab index 0 of the column. So it means that we are going to be able to grab this 1 right here. In order to grab it, we're going to say nums 0 and 0. So using this, we should be able to print out 1 in the terminal. So I'm just going to come right here and run this code. Now, once I run it, it should print 1 for us in the terminal. So I'm just going to run that again. Okay, I hadn't saved the file. Let me save it and run it. So once I run it, you will notice that it prints 1 out in the terminal. So let's say, for example, I wanted to print 2. It means that we are still printing from row 0 because it's we're using the indexing. We're printing from row 0 and we want to print the second column. Since we're using indexing, we're going to leave this as 0, and then we're going to set this to 1 because we're trying to print from row 0 index 1. So if I clear the terminal right now and I run this, it's going to print 2 for us in the terminal. So let's say I wanted to print 9, for example. We know that 9 is in the third row, but using indexing is going to be 2 because this is 0, 1, 2. So we're going to say 2, and then we want to print 9 also. Because 9 is in the last column, it means that we are going to also say 2 because this is 0, 1, 2. Now, once I save that and I run this in the terminal, it's supposed to print 9 out, which we can see here in the terminal. So that is how we can model two-dimensional arrays. Now, you could have as many elements as you want in an array. You could have like 10 rows and 10 columns, and you could populate the arrays with whatever data you want. It is up to you. Now, there's also something else that I would like to explain to you, how to print out the elements inside a 2D array using a for loop. Now, in order to do this, we are going to require 2 for loops. Now, the first for loop is going to loop through all the rows, and the second for loop is going to loop through the columns in each row. So I'm going to show you how it works. So first, I'm going to write the for loop. Now, we need to take note that we have 3 rows. So I'm going to say for int I equals to 0. I'm initializing I right there. For int I is equals to 0. Now I'm going to say, well, I is less than 3. And I'm going to say I plus plus. Now I am going to explain what this means. So what we're saying is that for I is equals to 0, so we're going to start at index 0. Then we want to say while I is less than 3, it means that we're going to loop from 0, 1, and 2, so that we can grab the 0, 1, and 2 indexes. So while we're going to say for int I is equals to 0, I less than 3, I plus plus. So for each iteration, it's going to increment the value of I. Then we need to write a second for loop inside this first for loop, which is going to loop through the columns in each row. So when we run this first for loop the first time, it's going to grab this first row because I is starting from 0. So we're going to say for int I is equals to 0. Then what we now want to do is write a for loop that is going to loop through this entire array, which is at the 0th row. I'm going to write the for loop and say for int j is equals to 0 also, and I'm going to say j less than 3, then j plus plus. So what does this mean? We're trying to say that, okay, loop through the first item and loop through all the rows. After looping through all the rows, we now want to loop through the column in each row using j. So what I'm now going to simply say is I'm going to say printf, and in here I'm going to say %d print %d, then I'll put a comma and say norms of I and j. So I'm going to explain what this is, but let me just put a \n right here. So right now we're going to loop through all the rows. Then for each row that we loop through, we're going to loop through all the columns in that row. So let's say, for example, we run the program. It's first going to start from index 0. Then it's going to come to this first for loop. Then it's going to loop through all the items. Because we're saying from in j equals 0, then while j is less than 2, it's going to loop from 0, 1, 2, and then it's going to print out the value of I, value of it's going to print out the value of whatever index it is using the row index and the column index. So let me run this and let's run this and see what we get. So you notice that it prints from 1, 2, 3, 4, 5, 6, 7, 8, 9. So what we're successfully able to do is that we were successfully able to create a 2-dimensional array that has 3 rows and 3 columns, just like we have in this picture, almost like a matrix. And then what we're now able to do is we were able to print out all the items inside this array using 2 for loops. The first for loop goes through each row, and then for each row, the second for loop goes through each column and prints out all the items in the column. Now after it has finished printing out all the items in the column, it now goes back to this loop, and then this loop increments itself and moves to the next row, and that is how all the items get printed out in the terminal. So that is just like the very basic explanation of how 2-dimensional arrays work in C. So in this video, I'm going to talk about memory addresses and explain what a memory address is to you. Now, all through this course, when you've been creating like variables, for example, you've specified the data type, you specified the variable name, and you've equated this to the value. Now, to you, this is how to create a variable and this is how it is stored. But I want to explain to you that there is a different way that C actually stores this variable. And how C actually knows where this variable is and how to access it. Now to you, if you wanted to access this variable, this value of 2024, you can just reference the year variable, which you could print out here. For example, if I wanted to print out the value of year, I could just reference the year variable and to print out the 2024 value. But the way C stores these items and the way C retrieves it is very different. Now, there's something on the computer called RAM, random access memory. And when you create a variable and you equate this to some value, what C does is that it takes that value and it goes to some random location in the memory in your RAM, and it stores that value and it keeps track of the memory address of that value, so that when next you want to reference it, like for example here where I am printing here, it doesn't actually reference the variable itself, but it references the memory location of where that value is stored in on your RAM. So I'm going to give you an example right now. So let's say, for example, I wanted to print out the memory location of where 2024 is stored. I'm going to remove this %d and put %p. Now what the p stands for is pointer.
Now, it just simply means that we're trying to print out a pointer location to where a specific value is stored. Now, another thing that we'll have to do is that we need to specify that we want to print out the pointer of the value of 2024. So in order to do that, we're going to pass in %year. So %year is just going to return to us the memory location or the memory address of where this value is stored. And in order to print it out, we need to specify and say %p. So once I save that and run this code in the terminal, you're going to notice that it prints out this very weird text. And we can also do the same thing for month. So I can come down here and replace year with month. And once I save it and run this code, it's going to print out a different memory location. So what C did is that it took these values that we had created. For example, here I created a variable, an array called a string or an array called month, and I'm storing the value January in it. What C did is that it took this January, this value right here, it went to your RAM, which is your random access memory, and it assigned this and it's kept it in a specific place in your memory. And in order to access it, all it needs to do is go to this memory location and check, okay, what is the value that was stored in this memory location, and it's print it out. That is how C actually works under the hood. The way we do our own things for programmers, we just define the variable and we equate this to the value. And we know that anytime we want to access that value, all we need to do is reference the variable name that we give to that value. But for C, when it wants to access that value, it references the memory location or the pointer address to where that memory was stored on our actual computer. Because every time we create variables and assign it to specific values, those values are actually temporarily stored on our computer in the RAM. And the RAM generally is where running programs are executed. So for example, when you open an application like Adobe Photoshop, it is moved from your hard drive to the RAM, and then all the processing and all the memory operations that it needs is done on the RAM. And once you save it and you are like closing the program, it is moved back to hard drive. So that is how memory addresses actually work. And in next video, we're actually going to talk about pointers and how pointers work. Welcome to this YouTube video. So in the last video, we talked about memory addresses and how C actually stores values in your RAM and how to retrieve those specific memory addresses and print them out. Now, in this video, we want to talk specifically about pointers. When we're talking about addresses, we said that anytime we create a new variable and we assign it to a value, we said that C actually takes that value and stores it in a specific memory location in your RAM. And then we talked about how to print out that specific memory location in the address and in the video we did last time in this course. So what we're going to do right now is we're going to talk about creating a pointer variable, and we're going to talk about pointers in detail. Now, I know pointers have had this reputation of being very difficult, but actually very straightforward. I want you to think of pointers as a specific kind of data type. The way you have the int data type, the char data type, you could also think of it as its own specific kind of data type. And anytime we create a pointer variable, all we are simply saying is that this variable is going to store the pointer location to another variable. So let's say, for example, I'm going to give an example now. Let's say, for example, we wanted to store the pointer location to the year variable. What we're going to do first is we're going to first specify the data type of the value, which is int. So we're first going to say int, and we're going to say star. Then after star, we need to pass in the name of the variable that we're going to assign to this pointer value. I'm just going to call it year pointer, and I'm going to equate this to %year. So what exactly does this mean? We have specified that with this variable called year pointer is going to store the pointer value by specifying star in front of it, and then we equated this to %year. So when we say %year, it's just going to return to us the memory location of this specific value, just like what we did here when we're printing out the memory location of the month variable. So right now,
and %year is going to give us the pointer address to the year value, which is 2024, and then it's going to assign us to this year pointer value variable, I mean. And then this is the pointer variable because we put star specifying that it is going to be assigned to a pointer address or a memory location of a different value, or a different value, yes. So what we now need to do is, if we wanted to print out the memory location for year, what we could first do is we could come down and say %year. Let's just ignore this one for now. We could come down and say %year, and once we run this code, it's going to print out the memory location for year. But what we could also do is, since we've created the pointer variable right here, which is assigned to the memory location of year, we could just remove this year and then pass in year pointer, because year pointer is also equal to the memory location of year. So once I run this code again, it's going to print out the memory location again, because we were able to store it there. Because it's going to print it out again because we were able to store the memory location in the year pointer variable, and we were able to print it out using the %p data type specifier, and we passed in the year pointer value into this. So that, now there's also something I would like to talk to you about. So you know that in here we're storing the pointer variable, the pointer to this specific value in this year pointer variable. Now there's something called differencing. Now this is when we try to access the value that is stored in a specific pointer location. So it's called like differencing pointers. So for example, this variable called year pointer is assigned to the memory location of year, which is a pointer, a memory address or a pointer. So what if we wanted to access whatever value was stored in this memory address? All we need to do is, if we're printing it out, we need to replace the %p with %d, because we're going to print out a decimal number. Then what we now simply need to do is just say star right here. Now, if I clear out my terminal and run this code, you'll notice that it's going to print 2024 out to us. So anytime you want to print the value of a pointer, the value that is stored in a specific memory address or pointer, what you need to do is just type star, then the name of the pointer variable, and it is going to print out whatever value was stored in that specific memory location. So that is all you need to know basically about pointers and differencing pointers. So we have a variable called year, and it's equals to 2024, and we have a different variable, and it's a pointer variable called year underscore pointer, and it is referencing this year variable. We said %year to get or retrieve the memory location or the memory address of this variable, and we assigned it here. So what we can now do is, in order to print out the value, we first needed to replace the data type specifier. We needed to change it to %d, and after doing that, what we now simply did was passing star, then the name of the pointer variable. So that is how to print out the values that are stored in a specific memory address. So thank you for watching this video, guys. And if you have any question in this entire course, or if you've had any question or you want to reach out to me, just leave a comment in the comment section below, or you can reach out to me using the contact details in my channel information. Thank you for watching this, guys, and it has been a fun experience making this course. Thank you for watching, and I will see you in the next one.